Who's that? Please mute. Okay, do PAT simple t-test. The purpose is to test the difference in measurement between 2 time points. What's called PAT? The same person measured before and after. And then this results comes out. You look at the p-value, less than 0.05, conclude there's a difference. More than 0.05, no difference. In this procedure, there is an assumption that the difference score must be distributed normal. So if the difference scores are distributed normal, yeah, green lane, then we do parametric test. If they're not normal, red line, we do non-parametric test and we do the conclusions. Okay, let's start with the first one example. Right, this example. So before testing the difference in mean, you must test assumption. What's assumption? What is the assumption? Class, what's the assumption? This assumption, this test?
Different scores if it is big
Different
distributed.
scores must be distributed normal. Okay, the different scores must be distributed normal. So in the data set, that's the data set. What must you do first? What must you do first?
Check normality.
Normality of what? Assumption says normality of what?
Different scores.
Different score. Do you have different score here? Is there a variable
Distributed.
different score?
Explore.
What must you do first?
Analyze, go to explore.
Now, what must you do first? Look at the slide. What's the assumption? What is the assumption? Assumption says
If it is
The difference score must be
different
distributed
score must be
normal.
normal. Different score. Do you have the different score here? This before,
Yes.
this after.
Yes.
Do you have a different score?
Yes.
Yes, sir. Where's the different score?
So it's what
We need to compute.
computing. Yeah. We don't have, so
Now,
it's
others
the
are
calculation must.
right. What's the difference here? First one.
Plus 10,
Yeah.
plus 10.
10.
Yeah.
Hmm?
5, 1.
Next one. What's the difference?
5.
5. Next one.
1.
Gained 1.
Huh?
Gained 1 kg.
Now, what's the difference I'm asking?
Plus
1.
1, plus 1.
Plus 1 or minus 1?
Minus 1.
Minus 1.
180 minus 170 is 10. 160 minus 155 is 5.
Yes.
160 minus 161 is minus 1, right?
Yes.
Is it the way to do it?
Doctor, is it not absolute value?
No, you must take the actual difference, not absolute
Ah.
value. Actual difference.
All right.
Because it says what? Difference, right? Difference
Yeah.
term
Mm.
will be positive negatives.
Mm.
This is the only way to do it. How many cases? 16 cases can do. What about 16 million cases? Can you do it?
Ah, yeah.
No.
Auto.
Not feasible.
Very difficult.
Not feasible. So you want to know how to do faster?
Yes.
Okay, delete this. Go to transform, compute. Transform, compute. Compute what? Let's call it difference. Or just GIF. Give a variable name. I call it difference. You can call it whatever you want to. You can also put a name there, monkey, donkey, whatever. On the other side, numerical expression. Don't type anything. Double click first variable, BP, double click. What happens? Does it goes into numerical expression box?
Yeah, minus.
Yeah, minus.
After.
Right, that's all.
Yeah.
After,
So,
yes.
when you click OK, and see how fast gets filled out. All right, all the difference is done. The signs are important. So doesn't matter 16 cases or 16 million cases, split second, whole thing is calculated. Again, what's the assumption? What's our assumption?
Are normalized.
So what's the assumption?
Are distributed
Distributed
normally.
normal.
The
Difference
difference
score.
score, distributed normal. Have you got the difference score?
We got it,
Right.
but
How to test for normality?
We need to study distribution.
Ankita, tell how to do it.
Before
Ankita?
minus
Analyze.
Huh?
We go to analyze,
Analyze, all of you.
descriptive
Analyze, descriptive statistics,
and explore.
and explore. The test of normality in SPSS inside this procedure. Right? Explore. Which variable?
Differences.
The differences. Put inside. What's next? Ankita, what's next?
Just press
Plot.
plots,
Plots.
then choose normal and plots with the test. Then okay.
Right. That's all. Decide the descriptive statistics, very important. Continue and click OK.
Okay.
So look at third table. Test of normality.
Normality.
There are two tests here, right? KS and SW test. Which test will you use in this case? SW or KS? Homographs or Sapir-Whorf? What is sample size? DF is sample size.
Differences, yeah.
Is it a
the
big?
same.
Now this DF represents sample size. Is it big sample size or small sample size? The cut point is 50. More than 50,
I think it's big.
consider this. Less than 50, consider small. So in this way, this case, we'll use a Sapir-Whorf test. Don't have to mention it. I should know which test to use. So what's the p-value in this test? Is it more than or less than 0.05?
More than 0.05.
More than 0.05, right? So that p-value is more than 0.05. So we are the green lane. That means we can do parametric test. Are we clear? Class, are you clear?
Yes, sir.
Okay, if this p-value is, what about now?
Less than 0.
Less than 0.05, therefore,
Go for
No,
it is not normal.
normal.
The difference score is not normal. So difference score not normal, then you're here, we do the non-parametric test. That's all. Much simpler than the independent t-test and your one-way ANOVA. All right, so back to our slides. So we tested this, right? So we computed this way and tested this difference score, test of normality on the difference score. So that's a p-value more than 0.05. I don't know why the data be different, doesn't matter, okay? P-value more than 0.05. Therefore, assumption of normality is met. That's the case. We proceed with parametric test. All right. So follow this procedure. Do the parametric t-test. Anne, are you there, Anne?
Yes, I am, sir, but
Okay.
I'm not able to get onto my SPSS, but I can follow.
Okay, but is the slides with you? The slides?
No, these slides are not with me at the moment. Sorry.
Okay. Who else want to guide us through this analysis? Any volunteers want to guide us? Take us through? Any volunteers? Zaber? Zaber?
Yes, sir.
Okay,
Is it
tell us
me?
what to do.
Okay.
Tell us how to do it. Okay.
Okay. We go analyze,
Analyze,
printed sample test. Go this printed.
No, you just follow this.
Compare means.
Ah,
Compare means.
Slice, compare means. Then
Then go print
pair.
sample t
Sample
test.
t-test.
Yeah.
It's all
Yeah.
right.
Then we select two before and after.
Click before, highlight, and click in the button.
Yeah.
Goes there.
Okay.
Select,
So
after, click
before
in.
then we're gonna study if you
So, very pair, isn't it?
Yeah.
Pair one. That's a pair value, variables.
Mm.
Or after. So that's a pair. That's all right.
Okay.
Let's do one more time. Let's do it. Tell us one more time.
Okay, we do analyze.
Analyze.
Compares means.
Right.
Compare means.
Yeah.
Create sample t-test.
T-test.
Then we're gonna select two before
Click.
and afters. Yeah.
After.
Click.
Can I do the other way around? Before first, then after.
I think you can do it, but maybe, yeah, I think
Doesn't
maybe
matter.
just doesn't match symmetric things in the yeah.
Right? It doesn't matter.
Mm.
Like to follow the same step. Before, after, it's fine. Just click OK. Right. Look at the table results. Okay. Ignore the second table. Paired sample, ignore this time being. Right. Just two tables. So what's the first table? First table?
Report the means.
Right. Sorry, the data will be different. Okay, doesn't matter. These values are different. Okay, what's
Never
the mean
mind. Yeah.
before? Mean before?
154.
154 plus minus 14.
14. Yes.
After?
After 150 plus
minus
14.5.
Right. Okay.
Yeah.
How much difference? How much difference?
4 point something.
Oh,
3 point something. 3 point something. Yeah.
3.688. That's the mean difference, right? Before minus after. 154 minus this. That's the mean difference. The mean before plus or minus. Mean after plus or minus. This is a difference plus or minus. Now the p-value. So where's the p-value? The last one's the p-value. So what's the p-value here? Is it more than or less than 0.05?
Less than 0.05.
0.05. That means there is a. Now hold on. Now which test are you doing?
We are comparing.
Correct. Yeah.
To...
Correct, right? Correct. Right. Right. So look at the last column p-value here. Is it more than or less than 0.05?
Less than 0.05.
Less than 0.05. Conclusion: the p-value of the test is less than 0.05. There is a significant change in BP. From where to where? 154
to 150. Yeah.
Significant change. This value is not right. Correct this.
3.688.
And the standard deviation is 4.175. Yeah. So that is the mean difference. That's the standard deviation. That's a p-value. We say the difference. But also must say how much difference. Look at confidence interval. So the difference, p-value is this. The 95% CI for mean difference is, again, going to correct this, 1.463 to 5.912. So conclusion is that we are 95% confident the mean BP, the drop or the change in BP is between 1.46 and 5.19. Just two decimals. Are we clear?
Yes, sir.
Right. Let's see now. You want to write a simple report? How do you do this? Again, what's objective?
We are comparing to.
What's objective?
Okay, what we're gonna compare?
Zabir, are you a science student?
I'm here. I'm here.
Are
Sir.
you science student or the social science?
Computer science, sir.
Computer science, huh?
Yeah, computer science.
Okay. Ankita. Ankita, are you science student or
Computer science professor.
computer science? Who is science student here? This class, who is science student? Tan Wan Zin, are you science student?
Yeah, I'm science student.
Science student, okay.
Yeah.
What is your research on?
My research is the development of a cross-gram seasoning with reduced sodium.
Okay, now, in this study, what's objective? Objective is what you want to know. What's objective?
To develop a reduced sodium seasoning.
In this particular test we did.
Oh, in this test we did.
Yeah. Somebody say you want to see whether difference in mean. I disagree. What is that actually you want to know? What's the objective here?
The effectiveness of the drug on blood pressure management.
Is there any progressive or impact in the change? So the study of the change, we apply something and we see is it change or not something.
In a layman's term, what do you want to know? In a layman's term, what do you want to know?
How effective the drug is on blood.
To test if the drug is effective.
All right.
Test if the drug is effective. That's all right.
Okay. Simple phrase.
To layman, they want to know the vaccine is effective, right?
Yes.
The Pfizer vaccine, is it effective? That's all I want to know.
Yes.
But the test involves this particular, right, procedures to be followed. So when you say the drug is effective, when do you say the drug is effective?
When we see the means has implied huge impact.
When
there is a change before taking the drug and after taking the drug.
When there is a significant drop, isn't it?
0. Less than 0.05.
Right.
So
Effective means that this BP, right? BP must drop significantly, right?
Sure.
That's effective. So don't say there must be change in BP. No, my objective only is this, effective. What do you mean by effective? The BP must drop significantly. All right. So this is silent. We don't say this, but it's only this. All right. What test you did? Analysis. What test?
Paired samples t-test.
Paired samples.
Yes.
Right. Results. Okay, results first describe. Sample mean before and after. Okay. Results. All right. Sample mean before and after are this and this, right? Or can just say means before and after. So means before and after 154, 150. So mean changes this value plus or minus this value. You're telling how much has changed. Without this particular, the two sentences, we don't know what's happening. If I know this, even I don't tell this, still I know a drop of 154. Because for me, effective means there must be a drop. Otherwise, it's not effective. Now, p-value of the test. What's the p-value of the test? Give the value. Don't put less than. How much is that?
0.03, it's written here.
0.003.
Yeah.
Is it less than 0.05?
Yes.
That means what? There is a significant change in BP. Change here, which direction? Is it reducing?
It's reducing, yeah. So
right.
that's
the drop.
So the curve is drawing down, you know.
And also you want to know how much, by how much? The 95% CI for mean differences. So take it from here. That is from this to this. So what does it mean? We are confident 95%. The mean drop in BP, mean reduction in BP will be between these two limits. So that's my objective. This is my analysis. This is my results. And finally, my conclusion. So what's the conclusion here? Conclusion must follow the objective. To test the drug is effective. So what's the answer?
The drug is effective.
Yeah, I have to follow this in BP management. So you must tell the drug is for what, right? For BP management. A different drug for different things. So you found that there is a significant reduction in BP. So now we say the drug is effective. But I want to add this caveat. Statistically, right? Statistically, the drug is effective. Now I don't want to use this word yet, right? Okay. Here there is a significant change in BP. I want to add this word here. There is a statistically significant difference. Statistically significant change in BP. I want to emphasize the word statistically here. Right. So the drug is effective BP management, at least from statistical point of view. When I say statistical point of view, what's the other point of view? When I say from the statistical point of view,
maybe the side effects of the medicine. Maybe.
No, just talking about this. Reduction of BP about 4 points, is it sizable? Give the medicine to hypertensive person. The lower limit, 1.143, lower limit. This telling anywhere between 1.43, 63, and 5.9. This lower limit, is it very close to zero? This lower limit, is it very close to zero?
No.
No.
Yeah.
If the limit is this, 7, let's say this is 15. This lower limit, is it far from zero?
Yes.
Is it far from zero?
Yes.
It means what? Sizable change, right?
Yes, it is.
Now, just now, where was it just now? It was here. Very close to zero, right?
Yes.
Because can be anywhere between 4.6 and 5.9. The lower limit, however, the lower limit of 1.463 hardly misses.
Doctor.
Yeah.
Doctor, I have a class and I need to leave. Can I?
Yeah, sure.
Thank you.
Okay, right. However, in the 95%, I put CI, confidence interval, the lower limit of 1.43 hardly misses the value of 0. Hence, besides statistical, you also must look into this kind of a practical application, right? The drug, hence clinical relevance is questionable. Any doctor is going to show that you can change as much as low as 1.46. You see how much 1.46? I sit down and stand up. BP can change more than that. So this reduction, hardly anything to shout about. But so happen, statistically significant. Right? So conclusion, a drug is effective, at least from statistical point of view. However, the 95%, in the 95% confidence interval, the lower limit, this is the limit, hardly misses the value of 0. 0 means no difference. Hence, the clinical relevance is questionable. This is what most drug companies do. Anybody from pharmacy in this class? Anyone from pharmacy? Right. This p-value has been sold for billions and billions of dollars. So, clinically, I want to know how much I gain, not statistically, but this is a stats class, stats module. Of course, it says statistically significant, but must also be able to translate to practical application. Right? That's where application comes in. Don't simply say, oh, significant, yes. Questions? Right. Have we put an assumption anywhere? Have we said our assumption anywhere here?
No.
No. Right? The difference score was distributed normally. That is why you're doing the parametric test. The difference score was distributed normally. Followed. In the test of mean difference, the p-value was this. Let me complete. Because without this, the result is not valid. Right? So in the test of mean difference, the p-value is this. So now you claim that there is a significant change. The change can be anywhere between this and this. So conclusion, we just put a caveat there. Right? That is very important for practical applications. All right. Questions?
Prof,
Yeah.
for the conclusion part, some parts I'm not so understand.
Okay, which one? The drug, is it effective?
Yes.
Yes, effective. The sizable, this change is significant. And here, it is shown the p-value less than 0.05. That means that there is a statistically significant change. Right? So this,
Yes.
however, this based on the p-value. The 95% CI says your change can be anywhere between 1.463 to 5.19. This lower value 1.463, is it big or small?
Small.
Small. Change of blood pressure 1.46, very small. Means what? Hardly misses the value of 0. Or you put there is very small. Right? Very small. Hence, clinical relevance is questionable. Clinically, this drug, is it useful? Is questionable. Do you understand? There are two parts here, statistical significance and also practical significance. Practical is clinical significance. There are two things here.
Practical significant.
Statistically, yes. But
Yes,
clinically,
the first one I clear.
okay.
Yeah, this I'm clear. But for if the lower limit is very small,
Yeah.
then the clinical relevance is questionable.
I mean, clinically, as
Clinically.
clinically,
Clinically.
the change is not much. Okay?
Oh, okay.
It's not much, right?
Yes.
Not much. Only 1.463, not much.
Mm.
So you might say, hey, look here, don't depend on p-value alone. Look here, this value is very small. And take the method also, things may not work.
Mm. So if we want to see the practical change, for example, the clinical change, so we look for the lower limit only.
What about now?
It's very large.
Very large. All right, this becomes
So,
too large.
so it changed a lot.
So we don't mention this. We don't have to mention this because it is shown, right? 7.4 is very much different. So we say the drug is, that's all. The drug is effective because this number is sizable, very far from 0. 7 point change is high. So I don't put a caveat behind here. But now, it being very small, I must highlight this. Very small. So
Okay, I
the drug
understand.
things may not work. Things may not work. All right?
All right, thank you, Prof.
Okay. Questions? Okay, let's do the second one. Weight loss program. Open the data file. Weight loss. Okay, weight loss program. Okay, somebody tell me step by step what you're supposed to do. What's the first step?
Prof, the first step, you have to compute the difference.
Compute the difference, right? So if I have this chart, I have this chart with me. So this says first compute the difference, because we must do the test on the normality of the difference. How do you do the difference? Tell how you do the difference. How do you calculate?
Transform, compute,
Transform,
compute variable.
compute variable. Let's say, what do you type here? Target variable?
Different.
Weight difference or
Different.
You can type anything, okay? I will type elephant. What's elephant?
difference.
Before, minus, after. Can be any name, but to be relevant, okay, type difference. Right? Otherwise, can be any name. Make sure no space in between, no space. All right. Click OK. So now you have the difference score. What's the next step? First step, computer already. What's the next step?
Check normality.
That's for normality. How do you do that?
Analyze descriptive statistics.
Descriptive statistics.
Explore.
Explore. Variable.
Difference. Diff.
The plots. Normality plot with text. That's all. Okay. Now, Arafat. Arafat. Is Arafat here? No. Dave? Dave, are you here, Dave?
Yes.
Okay, Dave. Now, based on these results, SPS is the results here, you tell me in the flow chart, green line or red line? Green line or red line?
Hi, sorry, my mic, I had some problems.
Now, can you hear me?
Yeah, I can hear you now.
Right.
Green line.
Results.
Green line.
Yeah?
Green line.
Now, green line. Why? This
More than 0.05.
0.05. That means stay with parametric test.
Right.
All right. Good. Right. Parametric test, analyze, compare means, patch sample t-test. Again, before highlight, click in. After highlight, click in. That's all. Click OK. Right. Okay, look at the results. For a second example, weight loss program. What's the weight before and what's the weight after? Is there a reduction? Is there reduction in weight?
Very less.
How much?
Very,
Yes.
yeah.
Yes.
How much?
There is a reduction of weights. I think 1.474,
Pretty
right?
there. Pretty
Yeah.
calculate for you.
Yeah,
Difference
1.474.
between stable. This minus that, that's a value. So
Yeah.
mean before plus or minus, mean after plus or minus, difference plus or minus, right? So
Yeah.
you can write this part of the results. Okay, mean before plus or minus, after plus or minus. So what's the value here? I just rounded up, okay? 82 plus or minus how much? 9. Is it? Let's say 82 plus or minus 9. Next one?
80
80
plus or minus 8.9.
8.9 ATM, 8.9 or 9 line, right? All right, what's the change?
1.5,
1.5 standard deviation.
3.6, plus or minus 3.6.
3.6. So done here. You did test the normality, right? Just now you did test the normality, right? The difference normal, right?
Yes.
Right, that's clear. Now, you did on this test, parametric test. What's the p-value of this test? What's the p-value?
0.0095.
0.095. Is it more than or less than 0.05?
It's more
More.
than 0.05.
Now, what's the objective?
Our objective is to test if the drug is effective.
It's not drug, weight loss, right?
Oh, weight loss. Sorry, my apologies. Sorry.
Weight loss program is effective.
Yeah.
Right. If it's effective, there must be significant reduction, isn't it?
Yeah.
Right. How much reduced here? What's the reduction here? Only 1.5 kg, right?
Yeah.
Is this significant? No.
No.
Therefore, there is no statistically significant change in weight.
Right.
Right. So no change, right? Effectively will change. There's no significant change. Look at the confidence interval. What's the confidence interval here? Can you read? Negative.
0.282.
0.282 to 3.229. Now, where is 0 falling? Look at this interval. Where is 0? Is it outside or inside?
Inside.
It is inside. The 0 falls inside here.
Yeah. In between
0 falls inside means what? Perhaps there's no difference, right? 0 falls inside the interval means what? There's a possibility the difference is 0.
Yes.
Which means it remains the same, so no difference.
What about now?
There is a difference.
Where is 0 falling? Inside or outside? Yeah?
Yeah, it's outside now.
Outside here, right? If this is minus for some reason, okay, and this is a minus, where is 0 falling?
Then there is a difference.
The right.
Outside, right?
Yeah, that was
So just watch whether the signs are they same direction or different direction. So here, going from negative to positive must pass through 0, right?
Yes.
Right. So a negative to positive, there is a difference. Just now, when I did for BP, this is positive to positive, right?
Yes.
0 does not fall inside. So whenever the p-value is less than 0.05, this interval will not contain a negative. This example, where the p-value is more than 0.05, 0 will fall within. Then you say there's no significant change. So here, what's the conclusion? The program is not?
It's not effective.
It's not effective.
Yeah, so that can check through, yeah.
Right. the program is not effective. That's all.
Yep.
So we don't hit this also because not effective. That's no difference. Does not make a difference. Okay. The weight loss program is not effective. If it's effective, people want to know how much. But here, no difference. Values are close to zero. All right. Questions?
No.
Okay, let's do the third example. Muscular strength between the left and the right arms. So for the file, muscular strength, muscular strength, is it a pad measurement? Look at the screen. This before and after, is it a pad measurement?
The two variables, you mean?
Is it a pad measurement? Is it a
Yes.
pad?
Yes, it is.
Because same person measured here and here,
Oh,
right?
yeah, yeah, yeah.
So it's called pad. Now, this muscular strength, is it a pad measurement?
No,
Why not?
I think it is
Yes.
because it
For
has
a
to be the same
person,
person.
we have, fortunately, we have left and right, isn't it?
Yes.
This left and right belong to one person, right?
Yes.
So they are independent. My own left and my right. Ali's left, Ali's right. So this is a considered pad measurement as well. Okay, of course, there could be some underlying conditions before we can do any conclusion. But here, basically, want to know whether the strength does it differ between left and the right. Okay, first step. Step one, what must you do?
Compute the difference.
Compute the difference. Okay, compute the difference. Can somebody tell how to do this?
Transform,
Transform,
compute variable,
compute variable.
and then you write difference,
Okay, something.
and then you click on left,
Left,
double click, minus,
Minus.
right.
right, finish. There's no manual calculation necessary. Okay, so already there. So you already done number one, compute. What's number two?
Test of the
Test
difference.
the difference. How do you do that?
Analysis.
Analyze,
Analyze.
descriptive,
Descriptive.
explore.
Explore.
Which variable? The diff variable. Go to plots. Normality plot.
Normality.
Yeah. Okay. Okay, look at the results. Alina, are you here? Alina? Hardev?
Here. Yeah.
Alina here?
Yeah.
Alina, this is my results. Test the normality on the difference curve. Now tell me whether green line or red line.
Yes. It's right line.
Huh?
Right line.
Red line. Why? This is less than 0.05. Therefore, red line, the distribution is not normal. Then we can't do parametric test. So in this case, the parametric test cannot be done. So this is out. Therefore, we do non-parametric test because this p-value is less than 0.05. So go to non-parametric test. All right, let's do it. Okay, look at the slide. So test the normality is less than 0.05. Sorry, this must be based on this test, huh? Because small sample size. Right. Less than 0.05, scores not normal, therefore parametric is not valid. You must do non-parametric test. Next slide. So this is how we do the non-parametric. Follow this procedure. Analyze.
Non-parametric test.
Non-parametric. Legacy dialog. 2 related samples. Right? This one they call related, not bad.
So variable 1 and variable.
Right. Is this similar to what he did just now? Look at what he has. Is this similar? Okay, can't do it. All right. Again, pair. Left, click in. Right, click in. Complete. Same like a parametric test, right?
Okay.
So in the parametric test is now here. Okay. So this test is non-parametric. Wilcoxon test is non-parametric. The other tests also there for different reasons. The default Wilcoxon, just leave it there. Just click OK. And look at the last table. The last table. What's the p-value there?
0.02.
Is it less than 0.05?
Yes.
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 0.02. I think a mistake here. 0.02, which is less than 0.05. Therefore, there is a difference. There is a difference. But you can't say mean difference. Can't use the mean because why? The assumption is not met. So you can't use mean to describe. Okay. So how to go about reporting this now? What's objective? Objective? What's objective for this test? What do you want to know? Muscular strength, right?
To test the muscular strength differ between the left and right hand arms.
To test if the muscular strength differ between left and right. We have to test if the muscular strength differ left and right arms. So what test we did? It's not paired sample. We did non-parametric, parametric Wilcoxon sign test, parametric Wilcoxon test. Right. So now we highlight this first. Was the difference score normally distributed?
No.
So we're not going to do this. The difference score was not distributed normal. Hence we did. Hence the non-parametric test was used. All right, we're telling what we did. Let's look at the results in this test. What's the result? What's the p-value in this test? What's the p-value? The p-value in this test was
0.02.
0.02. 0.02. Is it less than 0.05?
Yes.
So what's the conclusion? There is a significant difference in strength between the right and left. Right. At this stage, do we know which is stronger?
No, we don't.
Right. P-value of the test is this. Therefore, there is significant different strength between the left and the right arms. Unless you tell how much, it's not easy to visualize. Instead of means, you're going to use? Instead of mean, you're going to use?
Median.
Median. The median strength.
I think.
The median strength for left and right arms. Well, okay, we're going to bring the medians. So now the question is, how do you find the medians? How do you find these medians?
Explore.
Explore procedure. So analyze, descriptive, explore. Which variable? For the left and right, both inside dependent list. There's no factor list. This one variable, this another variable, and click OK. Right, first table, second table. Left. How much was left? What's the median?
14.7.
14.7. Bracket. Bracket.
9.
Right arm.
15.
15. Bracket.
9.6.
9.6. So which is stronger?
Right.
Which is stronger? Right. Here we say there is a difference. This statement says the right is stronger compared to the left. So what's the conclusion? To test muscular strength differ. So what's the conclusion? Right arm is stronger, right?
Stronger, yeah.
Stronger compared to the left. All right. But a lot of underlying assumption, but just want to know this. Right? So non-parametric tests, they use ranks, right? Ranks, not actual values. Do you understand what's ranks? Class, do you understand what is ranks?
Yes.
Okay. So it is based on the ranks. But ultimately, we go back to medians to tell how much and the difference here. There's no confidence interval here. All right, 3 examples. So use non-parametric test. Okay. Now, what I've gone through are basic stats, basic statistical procedures in statistics, basic procedures in statistics. For a PhD, all this is not sufficient. We have to go to intermediate to advanced levels. To understand whatever you're going to do intermediate advanced level, you must understand the basics. What are you comparing? What are assumptions the test? How do you make conclusion? How do you compare statistical versus practical comparison? So these are things very important. Will help you in the discussion part. Okay? Questions?
Yeah, Professor, I have a question.
Sure.
See, actually, you're giving these steps, and it's like we are following that, and it's all fine. But it's like, how do we come to know? It's like what test needs to be used when you are talking about, like, say, Wilcoxon test. It's like on what basis is like we are arriving at why do we need to use this test?
Okay, no harm. You see, in the non-parametric tests, eh?
Yeah.
Are you talking about specifically non-parametric tests or any test?
No, for anything. It's like, say, whatever the test which you have said so far. It's like, how do we?
All right. That's why this is important. What is that you want to know? First, what is that you want to know? Okay, suppose it. What do you want to know? Let's start. That's objective, right?
Yes.
What do you want to know? Right? Want to know. Without this, you can't go anywhere, right? As a first class, ask you write inside a circle, area of interest, isn't it? The area of interest. Then I say, what do you want to know? That's your objective. Without objective, you can't move anywhere. For example, what do you want to know? Tell your experience. What is that you want to know? In your study, what do you want to know? This is going to be another assignment, okay? Okay, what is that you want to know?
Maybe we can take that example as
just give me any
weight.
Yeah.
Equal matter.
Second.
The weight.
Okay, now mind. Are the female
after the
more
weight loss
intelligent compared to male students? Is it one compared to intelligent compared to the male students? Is this something you want to know?
Yeah.
Right? Whether they're more intelligent, smarter, right? Are they smarter compared to the male students? Is it true? Is it true?
I don't know.
Yeah. I'm generally asking, is it true that females are smarter than the males? You are from universities, right? Yeah.
We're not sure at this point.
How do you measure this? How do you measure this? Means what? How do you measure this?
IQ test?
Second, IQ test. Right. Smarter means what? They are more intelligent. Your definition is intelligent, right?
Yes.
Intelligence. How do you measure intelligence? You say, how do you measure this? You said using IQ test. IQ test. In the IQ test, the scores, are they quantitative or qualitative? Now you must understand.
Quantitative.
Understand the difference between quantitative and qualitative. Scores are quantitative. Right? Example, 70, right? 100, right? This is all quantitative. Right? Quantitative. Now, gender. The two variables now, IQ and gender, two variables. IQ is measured quantitatively. Sex, gender?
Qualitative.
Qualitative.
Qualitatively. Qualitatively, how many levels?
2.
How many levels?
2.
2 levels. So among all the test studies so far, which test is most appropriate for this? We have done BMI versus gender, isn't it?
Yes.
Right?
Yes.
Is this similar to this quantitative?
Yes.
BMI was quantitative, right?
Quantitative. Yes.
You also, this is qualitative, right? So what test we use for this? What test did you use for this? BMI and sex. What test you use? Yeah?
Independent
Individual.
Sample t-test. Right? Independent samples t-test. So similar principle applies here, right? Similar to that, right?
Yes.
So you'll do independent sample t-test. So these are variables. So analysis. So always put the analysis as a focus there. Independent samples t-test. Or just t-test. So by following this, objective is very important. You have to ask him whether female students smarter than male students. Smarter here means what? Intelligence, you said. How do you measure this? Measure the IQ. How are they measured? Quantitatively. Okay, IQ is quantitative. We're talking about gender, 2 levels. So what's the test? Independent samples, t-test. Raja, are you okay?
Yes, sir. Yes, I understood.
Right, change this to objective is, you want to know, are the medical students smarter compared to science and art students? Is this procedure going to be the same? IQ test can be done?
Yes.
Yes. IQ, is it quantitative?
Yes.
Now here, I put major. What major are doing? Is it qualitative?
Yes.
Major qualitative?
Yes.
Whether medical, science, or arts is
Yes.
medical. Right? This is qualitative. How many levels?
3 levels.
3 levels. Is it more than 2 levels?
Yes.
More than 2 levels. Therefore, what test?
One way ANOVA.
One way. That's all right?
Yeah.
Okay.
Right. Yeah.
Now you want to know objective. What fertilizer to use? What fertilizer? Say the farmer has this problem. What fertilizer to use? That's his objective. So how do you proceed here? Fertilizer. Here talk about smarter.
Compare fertilizers, right?
Here talking about what? The yield, isn't it? Correct?
Yes. Yes.
The yield, right?
Yes.
How much? How many kilos? How many numbers you produce? The yield. That's a measurement now. Is there a measure? Is it quantitative or qualitative?
Quantitative.
Right. Let's say this is a yield. How much the plants will give when I use fertilizer. So this is quantitative. Now, the fertilizer. How many different types of fertilizer are going to use? Just 2 fertilizers. I'm going to compare only 2 fertilizers.
Then
okay.
Yeah.
T-test, right?
Yes.
Right, T-test. They're going to use more than 2 fertilizers.
More than 2. Then is one way ANOVA.
Qualitative. More than 2 fertilizers. Right? More than 2 levels. Or more than 2 types or levels. 2 types of fertilizer. More than 2 types of fertilizers. Okay, more than 2 types. So what test now?
One way ANOVA.
One way ANOVA. So far, what you've done, that's all you've done, right?
Yes.
T-test I went to use, ANOVA went to use. Of
Yeah.
course, there are assumptions. Yeah.
The other procedures would remain the same, what you said.
The same. All the same.
No, do we need to make any changes based on our individual process analysis, individual analysis?
No, this is only the basic analysis.
This is basic, it's fine.
This is much more than this.
Okay, okay, fine.
Rajan?
Yes.
You won't be using this for PhD, but these are the basics.
Okay, okay, understand.
All right.
Thank you, Professor.
Okay. Another example for, okay, now we want to know whether to teach statistics, okay, teach stats, traditional method or with software. With software. Which one are we using now? Teaching stats, traditional way or with software? Which one are we doing? Traditional means there will be formula. Traditional means there will be formula, manual calculation, and all this. Software, just enter data, click on button, right? Here will be no manual calculation. Ultimately, you want understanding or doing it. That depends, okay? Now, can you form the objective for this? Form the objective. What's our objective?
To test which teaching method is effective.
Right? To test if there is a difference in students' understanding students' understanding of stats, right? To test understanding of tests using traditional or software. Okay? Or they ask whether teaching is in software, is it better than traditional way? Is it okay? Objective?
Yes.
Right? Or teaching is teaching stats with software. With software. Better? Better? Traditional method. Okay. Now, what kind of design is going to be? Just now somebody asked about quasi-experimental, right?
Mm-hmm.
Who said that? How do you go about doing this? That means some students will go into class with software, the computer lab. Some will go with traditional method, right?
Yes.
How do you do this?
Mm.
Can you take the students and randomize them? Maybe class A, there are two classes there, class A and class B. Class A, again, this one of the assignments. Class A, there are 40 students. Class B, there are 30 students. Can I move the students from the class? These 40 students, split them. 20 goes to software, 20 goes to traditional. Can I do that? Divide the class into two. 20 using the software. Another 20, the traditional method. Is it one other way?
Yes, it is.
Right? Is it quasi-experimental? Is it experimental? Can I divide the class like that?
No.
Why
No.
not?
There's no control.
Yes.
There's a control by traditional.
Oh.
Can it be done?
Can be.
That means you're going to disturb the class, right?
Yes.
Take the student, okay, divide them. Okay, this class is running there, next class running there.
Mm.
But usually when we make 60%, 50%. I'm not sure if
Say again?
60%, 40%, something like this. Usually like
No, we divide the class into two.
Because you divide them 20, 50%, 50%. It's kind of
No, is it okay to divide them into two classes like this? One class split.
Yeah,
One goes software. Yeah?
I think it'll be better to just leave one class to do traditional and another class to do software, because it'll be easier to manage.
What happened? This guy come back to the class, he'll talk to the one, you did traditional method, right?
Yes.
So there will be data corruption, isn't it?
Yes.
The same class, right?
Yes.
They come back from their respective classes, they discuss what happened in the other class, right?
Yes.
So they share notes. So data corruption will take place. And splitting the class, moving the class is not practical. Therefore, we won't do this. Right? Then what do? We take another class. Class B. Okay. Let's say class B. Doesn't matter whether the numbers are same or not. As I emphasize that, it's not necessarily 40, 40. This class has 30 students. So one of the class is going to go for the software, other one is going for traditional. And all the students in the class will follow that method. Now this class A go to software or traditional? Class A.
Software.
Software. Why? So we randomize the classes. Randomize the classes. Right? into, randomize the classes into software and traditional method. Randomize the classes. Supposedly, so happened, this went to traditional, this went to software. We randomize. How do you do this? How do you do this?
Randomly.
How do you do this? Randomly, but how do you do this?
I think you pick them randomly.
Take a coin, flip the coin, right?
Yes.
Head means, let's say I go to class A. Head means you go traditional. Tail means you go software. So
Maybe
happen,
he goes A, B, 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 I, D, something like this. This is random, yeah?
or it take two cards, two papers, like a piece of paper, right? Put it down. Ask the class rep A and B, come pick one, isn't it? Right?
Yes.
So all the 40 students in this class will go by traditional method. We're not uprooting them. All the 30 students will go into the software. It's called quasi-experimental because the students within, they're not randomized. Students are not randomized. Only the classes are randomized. Right? This is called quasi-experimental. Right? Experimental. Again, it's an assignment I'm going to give you. You must tell me all this. How do you going to go about doing this? And then what test are we using? And how do you make conclusion?
Today don't teach, yeah?
Say again? That means the beginning itself, before you start your research, you must have all the ideas in place. What is that? I want to know. The farmer wants to use which fertilizer? You want to know? Fertilizer, okay. What do you mean? Which is better? Better, higher yield, better. Let's say in kg, right? Kg of the particular farm product. So it's quantitative. Fertilizer, is it comparing two fertilizers? More than two fertilizers, right? So here, what test finally? Finally, what test will you do? How do you assess? This is my objective. I randomize them. This one class, this another class. Ultimately, how do you test? What do you measure? What do you measure finally?
Yeah,
How do you assess which students are better? Exam?
Yes.
Is that it?
Yes.
Exam marks? Quantitative or qualitative? Exam marks?
Quantitative.
Quantitative. Class A or B, qualitative or quantitative?
Qualitative.
So this is qualitative. How many levels?
2 levels.
2 levels. So what test? What test?
Individual t-test.
Independent sample t-test? Finally come to that, is it? But what's more important is from the understanding of what you wanted to know, how you design it. The design is very, very important. Right? Can you give a name for the design? Finally, the measurement becomes a simple marks, right? Marks is quantitative, 2 classes A and B, this qualitative. So we know t-test. Now you know how to do the t-test.
Yes.
Collect the data and apply it. But remember, I remind you again, for a PhD, it's not this simple. This one, we call it a diploma level statistics. I'm not telling you a diploma level 36. So we expect much higher from you. And why we go to this? This is a basic understanding, grounding in stats. Right? Later, whichever analysis we do, we know how to interpret and write meaningfully. Rajan, are you okay?
Yes, Professor.
All right. Questions? Okay, no question, take a break. 10 minutes break, and we'll do bivariate analysis. All right? Okay, take a break.
Yeah.
Hi, Prof.
Yeah?
I'm Hardeep. I just want to ask if this